Good evening, everyone. Am I audible and is the screen visible? Please let me know if I am audible and is the screen visible.
Yes, yes.
Okay, thank you. So let's begin with the today's live interaction session. So okay, so welcome everyone to the NPTEL course on post-harvest operations and processing of fruits and vegetables, spices and plantation crop products. And this course is basically instructed by Professor H.N. Mishra from the Department of Agriculture and Food Engineering from IIT Kharagpur. I am Shikha Sharma and I am a research scholar in the Department of Chemical Engineering, IIT Guwahati. And I am the TA of this course for July 2025 semester. So this live interaction session is for week 2. So we will be basically solving some of the tutorial based questions which will gonna help you in assignment 2, which has the deadline of 6th August. So 3 more days you have to submit assignment 2. So if you have any doubts, you can ask during the class or at the end of the class. And I hope so. This is the topics which we are going to discuss today, which is module 2. Basically, we are today discussing module 2. So which has the topics like post harvest losses and the preventive measures, post harvest operations, handling and transportation, supply chain management and storage, quality assurance and quality assurance and quality control, QA and QC. So lecture 6 so this basically module 2, it is having 5 different lecture videos. So lecture 6 is is all about post harvest losses. Lecture 7 is about post harvest operations. Lecture 8 is about handling and transportation, and then lecture 9 is about supply chain management and storage, and lecture 10 is about QA and QC, quality assurance and quality control. So in today's class, we will be discussing some of the questions related to all these 5 topics. So let's begin with our today's first question. So what is the primary cause of mechanical injuries to fruits and vegetables during transportation? So we need to tell the primary cause for mechanical injuries for the fruits and vegetables when they are being transported. So option A is low temperature, B is high humidity, C is rough handling, and D is controlled atmosphere. So let's discuss the solution. So option C is correct, which is rough handling. So when we talk about the post-harvest losses, there are different factors which affect post-harvest losses. First is primary, and second is some are the secondary factors. So the primary factors includes like biological and microbiological, which includes like which are basically like consumption or damage by insects, pests, and animals also from the microorganisms. So it includes microorganisms, may include fungi and bacteria. Second primary factor which affect the post-harvest losses include chemical and biochemical, which means that there can be undesirable reactions along chemical compounds present in food like browning or rancidity. Third factor is mechanical. So there may be like spillage or damage caused by like abrasion when uh, fruits and vegetables are being transported in the some kind of vehicle, and bruising can also happen, also crushing and puncturing. So all these are the mechanical factors. Then physical factors, which includes improper environmental and storage conditions. So it can be like temperature fluctuation, more humidity, relative humidity, air speed is more, or like that, those factors will come under physical. Then physiological parameters are also there, which includes like there may be sprouting, which results in post-harvest loss. Then fruit can undergo senescence, or like respiratory and transpiratory changes can also occur. Then last primary affects post-harvest losses. It includes psychological, like human aversion or refusal due to the personal or religious concerns. So uh, these are the primary factors, and the another are secondary factor, which includes like biological, or it may include some mechanical factors. Uh, but we are talking about here primary factors. So in the primary factors, we need to tell what is the primary cause of mechanical injury. So we need to tell the reason of mechanical injury to fruits and vegetables when it is being transported. So it is rough handling. So rough handling can be like there can be vibration where fruits are being transported, or there can be compression of fruit, like there can be overfilling of the container and then compression of the fruits, or falling so maybe I can use PowerPoint. I'm so sorry for the inconvenience, but there is some technical problem. Okay, so we discussed about question number 1 already. So is this question clear to everyone? Is this question clear to everyone? Question this one. Is this screen? Oh, sharing. No, share. Okay. Technical problem today. Hello, everyone. Is the screen visible now?
Yes.
Okay. So is the question 1 clear now? Question we already
Yes,
discussed.
ma'am.
Okay. So let's move to question number 2. Which of the following statements is correct role of temperature in the deterioration of produce? So we need to tell that we have 4 statements. So we need to tell which statement is correct out of these 4 statements regarding role of temperature and about in the deterioration or spoilage of the produce. Uh, exposure to undesirable temperature results in physiological disorders such as freezing injury, chilling injury, and heat injury. B is an increase of 10 degrees Celsius above the optimum temperature increases the deterioration rate by times. So option third is saying temperature does not influence the growth rate of fungal spores and pathogens. D is saying environmental temperature has a minimal role in of produce. So anyone would like to share?
B, A and B.
A and B. Exposure to undesirable temperature will lead to disorders and 10 degrees Celsius, 2 to 3 falls. Okay. Anyone else? Suraj also told A. Okay, let's discuss the solution. So A is correct. That exposure to undesirable temperature in physiological disorders such as freezing injury, chilling injury, and heat injury. And rest, they are not correct. Let's see how. So first is saying environmental temperature plays a role in the deterioration of produce. So obviously that the temperature will gonna affect what is the rate of the deterioration of produce. So but we know that whenever we are increasing 10 degrees Celsius above the optimum, so increase in deterioration rate by 2 times. But here in option B, it is saying that it is a decrease in the deterioration rate. So which is not correct. Then we know that when we are dealing with temperature and biological rates, we use Vent-Off rule. So what Vent-Off rule says, we also discussed in the previous lecture slide, that within the physiological temperature range, the velocity of a biological reaction increases 2 to 3 folds for every 10 degrees Celsius rise in temperature. There is some. Yeah, so we know all that Vent-Off rule says whenever there is an increase in temperature, so if there is an increase around like 10 degrees Celsius, so biological reaction rate, it will increase by 2 to 3 folds. So we know this we all know this equation, that this is temperature, Q10 is temperature quotient. So it tells about the ratio of the at two dissimilar temperatures. So R1 is at T1 temperature, R2 will be at T2 temperature. So this temperature quotient relates radiation rate R1 and R2 with T1 and T2 respectively, which is temperature. Then physiological breakdown, basically, uh, it means that there is an exposure to undesirable temperature. So it results in many physiological disorders, like there can be freezing injury, there can be chilling injury, and heat injury also. So because of that, uh, if there is a like fluctuation in the temperature while storage, or if the complete cold chain is not maintained well with the temperature, so there can be like chilling injury, freezing injury. Also, like then like there is a absorption of some heat or in the product, the temperature will be very high and product can be sensible or it can be sensitive to temperature, the heat injury as well. So which is telling about option A. So which is correct, that whenever there is undesirable temperatures, there can be some physiological disorders can be happen in a food product. Means that there can be some the freezing injury or the chilling injury or the heat injury. So A is correct. It's not correct because it is saying is in the deterioration rate, whereas it should come increase. Like other two options, C and D. So pathology breakdown happens when there is a temperature fluctuation there, like temperature, if it's optimum temperature for the growth of the fungal or the fungal spores or the pathogens. So the pathogens can grow and it can affect the temperature can also microbes. So which is options saying temperature does not influence. So it should be it affects. the growth rate of fungal spores and pathogens. Then last D option is saying temperature has a minimal role in the determination of produce. So whereas uh, the uh, temperature has effect in the deterioration of product. So it the temperature affects actually the respiration rate and the transpiration produce. So obviously, if the temperature is affecting respiration and transpiration rate, so when there is a low temperature, rate will be low and the shelf life of the product will be high. While if the temperature is basically so what will happen? Respiration rate will also go increase and also lead to faster spoilage. So option A is correct, that this is correct statement. All B, C and D are incorrect statements. Is this question clear to everyone?
Yes, ma'am.
Okay. So today only 7 people join. I am taking attendance. Ma'am, screen not visible. 425. Is the screen visible? This
Yes,
screen is
ma'am. Now
visible?
it is.
Oh, okay, okay.
Yep, ma'am.
So this question, the connectivity was fine in this question.
No, ma'am. No, ma'am.
Okay, so is this question clear to everyone? Next question.
Yes, ma'am.
Okay, let's move to this question. Which of the following chemicals is commonly used to control spoilage and improve the quality of grapes? So there are these 4 chemicals: thio, benzazole. Second is
Ma'am,
ethyl
sound is
folate. Yes. What happened? What happened? Let me reconnect the meeting. Yes. Okay. I think now the internet's stable. Okay, so in the chat, everyone is saying sulfur dioxide. So let's
Sulfur dioxide.
see that. Yeah, so let's see that sulfur dioxide is basically so yes. So let's see the answer of this question. So sulfur dioxide is correct answer. That sulfur dioxide is the one which is used. This is the chemical which is used to control the spoilage of and the quality of grapes. Basically, this sulfur dioxide fumigation is basically done in the grapes to help it to control its spoilage and to enhance its shelf life. So SO2 fumigation is used to control spoilage and improve the quality of grapes. So this SO2 is basically the structure is like that, that S double bond O one side and S single bond O. So it has positive and negative charges and it can go in conjugation. So this bond can shift this side, this on from the left side, it can shift on right side. So it can go in conjugation. So this is the molecule. Uh, so SO2 is basically, it is an antioxidant and it can also act as a bleaching agent. In some cases, it is also basically a reducing agent. And it inhibits non-enzymatic browning and uh, the enzyme catalyzed it helps in like the inhibition of enzyme catalyzed reactions and it can help in control of the microorganism. Uh, so in when there is SO2, like we are doing SO2 fumigation, so what happens? The sulfiting process is there. So in that, what happens? It generally performed by gas fumigation or by immersion in solution. So this when we are treating with sulfur, so it can be done with two ways. Either the gas fumigation will be there, or there will be an like there will be some kind of bath which will having some SO2 generating compounds, and in that bath there will be immersion of the grapes or any fruits or vegetables, the targeted fruits or vegetables. And this chemical basically helps in preventing the spoilage of grapes and maintain their quality during storage and transportation. Usually, like in some papers, it has been reported that fumigation with 1% SO2 combined with 6% CO2 at 19.5 degrees Celsius, if this treatment has been given to the on the grapes, then what happens? It controls widow's spider. So this kind of spider, when like can be controlled with the help of the fumigation with 1% SO2, 6% CO2 at 19.5 degrees Celsius. Another example is that when there is a fumigation at 20 degrees Celsius for 3 months with 0.25 and zero point 0.5 and 0.75% SO2, it can uh, help in the inhibition of like 18% when we are doing 0.25% SO2, then 18% mortality or 18% death of the this bug. So this is millibug crawls. This is in grapes. So it will like when we are doing 0.25% SO2 treatment, then there will be 18% mortality. When we are doing 0.5% treatment of SO2, then there will be significant enhance, which is 73% mortality. And then if we are increasing more like 0.75% SO2, then this kind of be 100%, it will be inhibited its growth. So in grapes, SO2 is basically used as a fumigant because it is a very good antioxidant. It is a very good reducing agent also, and it inhibits various enzymatic, non-enzymatic reactions, and also control microorganisms. So we already saw these are the pests which are there in when we are this kind of spiders and this kind of bug. They can be inhibited by the help of fumigation with the SO2. The another chemical is like thiobendazole. So if we see this table, which is already presented by Professor Mishra, so he already explained that these are the different fruits or vegetables, are the chemicals used for the on the right hand. So that uh, this particular chemical, thiobendazole, so it can be used for treating banana, and it can also be used in treating carrot and cabbage. Then second is ethyl oleate. So this is basically used in the treatment of pomegranate. And then sodium phenylphenate is which helps uh, uh, in the shelf life for the fuming. Another kind of can be done like maybe immersion. So for the apple product, these are different other options. So first is this option, this for banana, then second pomegranate. So sulfur only the one which is for, and this sodium phenylphenate is for apple. So for grapes, C, which is sulfur dioxide, is the correct answer. So you correctly. So let's this question now, which is which of the four statements is correct regarding the size process? So first statement, peeling is done to remove unwanted or inedible material. Second is coring is done to remove central inedible portion using a corer. Third is saying that peeling is done to remove or to improve, to improve the appearance of the final product using a peeler. So we need to tell which statement is correct here. Anyone? Vishakha is saying A and B, and Suraj is saying 1 and 2. Both is same, right? So let's see which option is correct. So option C is correct, which is statement 1, 2, and 3. All of them are correct. So basically, whenever we are processing our fruit with any kind of treatment, like when we are going for low temperature treatments or thermal treatment or concentration or freezing or irradiation, for any treatment if we are going, we need to first do the primary operations in the fruit product. So in primary operations, we do sorting and grading, we do washing, then ripening. Which, if it's not ripened, if the fruit is not ripened, we should first uh, help first help the fruit are like to either uh, store in ethylene condition where ethylene gas is there to promote ripening, and branching will be done, then size, and then these kind of other uh, higher end or other treatments will be done. So first these primary operations are being done. So the last operation, primary operation, is size reduction. So in size reduction, what basically we are doing, peeling, coring and sizing. So in the peeling, done to remove basically or inedible material. So statement 1 is correct, that it is done to remove unwanted or inedible material. Then peeling is also done to improve the appearance of the final product using a peeler. So in peeling we use peeler to increase the final product appearance. So statement 3 is also correct. Coring is done to remove edible portion using a, so we see that there are like pineapples or there are sometimes like apples. So we do coring process. So what we do is we remove central inedible portion there. So all these three statements are correct. So in the peeling, we sometimes use flesh peeling for root crops. Knife peeling is done for citrus fruits. Abrasion peeling is done for caustic peeling for guava, orange segments, and plain peeling is done for onion and garlic products. So the last question was clear to everyone. We are moving to this next question. Is it okay? Okay. So Suraj is saying we can move to next question. So which of the option is correct related to the ripening of the food? So in this, we already, these are the primary operations. So these are the primary operation. In this, the third step is the ripening step. So we are now talking about ripening step. So we need to tell which is correct related to ripening. So let's see. Ethylene treatment can be used to obtain faster and more uniform ripening. Second is saying the optimum temperature range for ripening is 25 to 45 degrees Celsius. Third is saying RH should be maintained between 34 to 45% during ripening, and ethylene should be 30 ppm in the enclosed chamber is sufficient to initiate ripening. So please tell me. Okay, so Vishakha is already saying that option A is correct. Ethylene tree about ethylene treatment. Anyone else? So let's see. Basically, ripening is the process which refers to the physiological and biochemical changes of a fruit to attain desirable color, flavor, aroma, sweetness, texture, and thus overall eating quality. So basically, ripening, uh, when we say ripening is achieved, when there is the organoleptic properties like the flavor, aroma, they should, or the eating quality, they should be reached to optimum level. So the product can be consumed, and the physiological changes like the optimum size also should be reached to optimal level. Then we can say that it is properly ripened. So the process of ripening basically does not occur until fruit is mature. So what happens first is the cell division happens. One cell will be divided into two to four, like that, and exponential division will be there, and then cell expansion. All the cells, when they will be divided completely, then their size will expand. After that, they'll reach in the maturation state and then ripening, and after ripening, the further the fruit will be decayed. So in ripening of a fruit, it may occur either on the plant or after even harvest. So it depends on basically which kind of fruit is there. If a climatic fruit will be there, it will be ripen after harvest, and in non-climatic fruits, so there will be no ethylene production. So it should be ripened before harvesting. So let's see our question. So as Vishakha rightly mentioned, so ethylene treatment can be used to obtain faster and more uniform ripening, which is correct. So, but why option B, C, and D are not correct? Because at the optimal temperature which should be needed for ripening is 15 to 25, not 25 to 45. And then RH should be maintained between 90 to 95% when the fruit is going to ripen. So it should not be 30 to 45%. And then ethylene should be around 10 ppm in the enclosed chamber for initiate ripening. So it should not be 30 ppm, only 10 ppm is required. So option A is only correct, rest three are incorrect. So is this question clear to everyone? So we are moving to next concept. All. Suraj, you understood why all were not correct? Because there was inappropriate like inappropriate values. Okay. So now let's discuss about methods of oil extraction. So oil can be extracted from four different methods like chemical, high pressure. So in chemical, basically solvent uh, can be used for extraction of oil, enzymatic techniques like uh, you can say papain enzyme, or the enzymes cell degrading and cell wall degrading enzymes like pectinase or cellulose, they can be used. And then high pressure can also be used for extraction of oil. Then distillation method and mechanical method. In mechanical, there can be like hydraulic press or screw press. So these are the different oil extraction methods. So our next question is about oil extraction from the oil nuts. So which factor most significantly influence the hydraulic pressing of oil nuts? So we first let's understand what is hydraulic pressing. So hydraulic pressing is application of hydraulic pressure. So hydraulic pressure will be generated using some kind of fluid. So hydraulic pressure will be generated from a piston or a ram kind of arrangement. And here is the ram. So it will force all these oil rich material. So hydraulic pressure will be applied through a ram to digest or to press oil-rich material or oil-genous material mash. So mash is about like it can be a soft moisture mixture of crushed material. So it can be like uh, little moist or powder kind of or coarse powder kind of uh, oil seeds or oil nuts we will have, and we can apply hydraulic pressure to extract oil, and these oil will be put in a cylindrical cage. So when there is a cylindrical cage kind of situation in this system, the material will be there, and from above hydraulic pressure will be applied to take oil. So this result in axial compaction and radial oil flow through a lateral perforation. So here the cylinder will be perforated and the oil will come out, and it is raw press oil. So we can get oil. In hydraulic pressing, basically Pascal law is being applied, which says that uh, the change in the pressure applied to a confined fluid is transmitted undiminished to every portion of the fluid and the wall of the containing vessel. So whatever the pressure is being applied here is uniform in all the like parts of this vessel. So this is hydraulic pressing system. So in this hydraulic pressing system, which factors you think most significantly influence, like temperature, pressure, nut moisture content, nut particle size? Anyone? Any guesses? C, B. From Vishakha and Suraj, we got C and B. Anyone else would like to participate? Sandhya is saying also, Sandhya is saying A, temperature, and there's B is pressure, C is nut moisture content. Let's see. Okay, so B is correct, which is pressure. So this is hydraulic pressing. So what is happening? Pressure is being applied. There is a hydraulic pressure is being applied. So most important factor will be pressure. So pressure is the most significant factor in the hydraulic pressing, as it directly affects the amount of oil extracted from the nuts. So how much ever pressure we will gonna apply, the amount of oil will depend on that. So pressure is the most important because this is hydraulic pressing. Is this clear to everyone? Other factors will also influence like temperature, nut moisture content, because if the nut will having more moisture, then the yield of the oil will be low, because uh, that moisture will hinder oil extraction. If the nut particle size, obviously nut particle size will also affect, like if the coarse particles will be there or the fine particles will be there. In fine particles, more oil can be extracted. Temperature, if more temperature will be there, higher will be oil yield. But pressure in hydraulic pressing is the most important factor. So that's why B is the correct answer. Is this clear? Can we move to next question now? So next question is about cold pressing. So which of the following statement about cold pressing is correct? Cold pressing is carried out at low temperature to preserve oil quality. Second is cold pressing is typically results in lower yield compared to hot pressing. Cold pressing oil often retains more flavor and nutrients. Which option can be correct for cold pressing? D, 1, 2, 3. So, okay, you both are correct. D is correct answer, 1, 2, 3. So, in cold pressing, obviously, it is conducted at low temperatures to preserve the quality, and it results because as it says cold pressing, so obviously it will be conducted at low temperature, and it results in lower yields due to the absence of heat. So, the yield will be low in where heat will be high, the yield will be also higher. And then if the cold pressing is done, so more flavor and nutrition will be retained and more health benefits will be there. If the cold pressing we will do, then the heat or the temperature sensitive compounds will degrade. So this is kind of a system in cold pressing where this is the plant product, and this kind of a screw system is there, and it is being pressed and oil will come out, and there will be like some kind of arrangement for uh, keeping the temperature low. So let's discuss about pre-cooling. So pre-coolings are basically done to prolong the shelf life of fruits and vegetables by removing the respiratory heat, because when products are coming from directly from the agriculture field, they are they have more and just they just pluck from the tree, so their respiratory heat will be very high. So pre-cooling is done to remove the heat and also to reduce the metabolic activities. So when respiratory heat will be high, so obviously faster deterioration or more metabolic activities. So so pre-cooling is usually done to increase the shelf life of fruits and vegetables. Pre-cooling basically inhibits microbial spoilage, restricts enzymatic and respiratory activity, inhibit water loss, reduce ethylene production. So, since it's a low temperature, obviously the microbial spoilage will also be low, and the other enzymatic and the respiratory activities and the water loss will also be very low. And there are in this table on the left hand side, there are different fruits like grapes, and they have the pre-cooling temperature. So this is an example that grapes they are having 1 to 4 degrees Celsius pre-cooling temperatures. Potato, they are having 5 to 9 degrees Celsius pre-cooling temperatures. So mango, tomato, and banana, they have greater than 10 degrees Celsius pre-cooling temperature. And there are different methods for pre-cooling, like room cooling, forced air cooling, ice cooling, hydro cooling, vacuum cooling, cryogenic cooling, and evaporative cooling. So there are different methods for pre-cooling. So this question is now based on hydro cooling, which is a kind of pre-cooling method. So this is hydro cooling. We are now discussing this question on hydro cooling, which of the following statement about hydro cooling is are correct. So we have 4 statements and we need to tell which statement is correct. Like produce is cooled by cold water either by immersion or showering. Second is heat transfer takes place by radiation. Third is produce does not dehydrate but gets clean by reducing the primary inoculum load. Fourth is stem, leafy vegetables and some fruits and fruit type vegetables can be cooled by this method. So, any guesses which option can be correct? So, C option 1, 3 and 4 as per Vishakha. Any other person? Tanishk is also saying C. Okay, let's see. C is correct. They both are correct. So in hydrocooling, what happens basically? Reduce is cooled by cold water, either by immersion or showering water. Heat transfer in this method takes place with the help of conduction or convection, but not by the radiation. So this second statement is incorrect because it is saying radiation, but basically heat transfer is due to conduction and convection. And first statement is correct that it can be from immersion or showering method. So in this diagram, it is also like the shower type hydro cooler is also, this is in picture, it is depicted. So next is produce does not dehydrate but gets clean by reducing the primary inoculum load. So due to hydrocooling, cleaning will be there and not product it like it's not for longer time, like the immersion or the showering with water is not for the long time. If it's for long time, so it will uh, the product can get some kind of moisture or water, but due to it will be done for very less time. So it's just for cleaning to remove the dirt and initial microbial load. And stem, leafy vegetables, some fruits and fruit type vegetables can be cooled by this method. So all these, because this wide variety of fruits and vegetables can be cleaned because it's like either the immersion or the showering. So these kind of method can be applied for wide range of products. So let's discuss a little bit about shower coolers. So shower coolers, they distribute water using a perforated metal pan. So there will be here perforated metal pan, and that is basically flooded with cold water. So from this cold water will come from the uh, refrigeration evaporator system, and here on the conveyor belt at the bottom, the product will be there. So it can be built using a moving conveyor for continuous flow operation, or it can be operated even in the batch. So from here, water from above, water will be cold water will come, and at the bottom, the food product will be there. In immersion kind of system, there will be this kind of water bath. So it will be used for the product that sinks in water. So product with high density, like the density more than water, can only be used in this type of immersion coolers. They usually cool slower than the shower cooler because water flows at slower rate past the product. So here in this uh, pro product, this kind of conveyor belt product will be there, and product will come and go. This is immersion tank where there will be continuous water supply. But since this kind of tanks will be very large, so the water replacing rate will be less. So the water will not be like cooling that fast like shower cooler system. So let's now discuss another type of cooling system, which is cryogenic cooler. So if we see here, this is pre-cooling method. In this, there is one another method which is cryogenic cooling. So now we are discussing about cryogenic cooling. So we should tell about these are the four statements and which statement is correct regarding cryogenic cooling. So the use of the latent heat of evaporation of liquid nitrogen or solid CO2 or dry ice can produce boiling temperatures of minus 196 degrees Celsius and minus 78 degrees Celsius respectively. Second, in cryogenic cooling, the produce is cooled by conveying it through a tunnel in which the liquid nitrogen or solid CO2 evaporates. Third is cryogenic cooling is relatively expensive to install but cheap to run. Fourth is the main application of cryogenic cooling is in cooling crops such as soft fruits which have a seasonal production period. So, which is correct? D, A. Okay, D and A. Okay. So C is correct answer. 1, 2, and 4 are correct answers. 3 is not correct. So in cryogenic cooling, what happens? The use of the latent heat of evaporation of nitrogen or dry ice or solid CO2 will be there to produce boiling temperatures of minus 196 degrees Celsius and minus 78 degrees Celsius respectively for pre-cooling. So obviously, since we need to remove latent heat of the product, latent heat of evaporation of liquid nitrogen. So liquid nitrogen is minus 196 degrees Celsius, its boiling temperature, and dry ice is minus 78 degrees Celsius. So they'll take heat from the product, this liquid nitrogen and solid CO2. They will going to take heat from the food product and they themselves will be boiled. In cryogenic cooling, what happens? The product is cooled by conveying it through a tunnel in which liquid nitrogen or solid CO2 evaporates. Since they will take temperature from the food product and their boiling point is in minus, so as soon as they'll get temperature from the product, they will themselves going to evaporate. However, at the above temperatures, the product will freeze and thus be ruined as a fresh market produce. So this problem is prevented by careful control of evaporation rate and conveyor speed. So since the product can be freezed, so it will be the texture of the product and the overall quality will be of the product can deteriorate. Because when the product will be freeze, we should either maintain a cold chain or we should, if the product will come at the room temperature, all the water will like they will mostly like they will be out from the product or the from the fruit cell. So product texture may deteriorate. So we should keep look about the evaporation rate and conveyor speed. Cryogenic cooling is relatively cheap to install but expensive to run because we should always need liquid nitrogen or solid CO2 and the whole system, like, and we also should keep the conveyor speed very fast, so that the time, the contact time will be less. So because of that, cryogenic cooling system, they are expensive to run. And last is its main application is in cooling crops such as soft fruits, which have a seasonal production period, because the seasonal product, because we should have a particular batch of products which are in large quantity, so that we can do for the seasonal production period only. Uh, and these are basically used for soft fruits, because hard fruits, they will gonna lose their texture. Uh, so they will be used for soft fruits. So C is correct. So 1, 2, and 4 statements are correct. 3 is not correct. Is this question clear to everyone? Can we move to next question, which is about quality of fruits and vegetables? So we should tell which is the like major factor which affects quality of fruits and vegetables during transportation, like temperature, control humidity levels, and physical handling. So D, which is only 3, physical handling. All. So Vishakha is correct that it is all. 1, 2, and 3 all. So because environmental factors, like so they all basically are environmental factors, and they like 1 and 2 especially, so they deteriorate the quality of fruits and vegetables, like temperature, then relative humidity, atmospheric gas composition, and light also. They all affect, these all are the environmental factors which affect uh, basically which affect the quality of fruits and vegetables during transportation. Like temperature, basically, if we control the temperature, so we can slow down the deterioration process. So as we discuss in Van Dorf rule, that if we increase the 10 degrees Celsius, then there will be increase in the deterioration by 2 to 3 folds. So if we decrease the temperature, so we can preserve the fruit quality. Exposure to undesirable temperature also results in many physiological disorders. So, like freezing injury, chilling injury, and heat injury. So, if there is a fluctuating temperature, so these temperature related injuries can be occurred in food products. Temperature influence growth rate of fungal spores as well, pathogens. So, obviously, at high temperature or at around ambient condition, the growth will be very high. It affects the, obviously temperature affects respiration and transpiration rate of the food product. So we know that this Arrhenius equation is there, which tells how the temperature T is related to K, which is rate constant of any kind of reaction. So here EA is the activation energy, R is universal gas constant, which is 8.314 joule per Kelvin mole. T is temperature in Kelvin. A is frequency factor or sometimes we say Arrhenius constant, and K is rate constant here. So when there is a higher temperature, so we see at low temperature the rate constant is also low, but as we increase the temperature, there will be 2 to 3 times increase in the rate constant. So there is a rapid increase in the rate constant value. So in this question, so if we see here, in assignment 2, so this is question number 8. So in this question number 8, this question will be solved with the help of this equation only, Arrhenius equation only. Like they have already given in this question, first T, R, E, A, K. So you should calculate A. Afterwards, you should put value for another and should calculate calculate the rate constant at 130 degrees Celsius. So like this type of questions can be solved using this Arrhenius equation. Let's continue our discussion. So product temperature, so the like the product temperature, it also affects affects overall respiration rate, and overall it affects the product quality. So it influences the metabolic and determines deterioration rate. Increase, if there is an increase in the temperature, perishability will be very high, and overcooling if we are doing, then chilling injury may occur. So desired or optimal temperature should be maintained, and when from farm to fork there should be refrigerated condition should be maintained, or a kind of cold chain should be maintained. Relative humidity also affects directly the growth of the microorganism, and it also correlates with temperature. So the combination of the relative humidity and temperature, they can elevate or reduce the rate of deterioration. If we see the combination, so relative humidity, it can be like if the temperature is high and relative humidity is low, the deterioration is very high. And if high temperature is there and high relative humidity will be there, the deterioration rate is high. If low temperature is there and low relative humidity is there, then deterioration is moderate. And if low temperature is there and relative humidity is high, then deterioration is low. So both the combination of RH and temperature, they also affect the growth of microorganism and also the overall fluid deterioration. So we know that if we see this graph, that water activity versus relative reaction rate, so we can see greater than, like here it's saying 0.7 mold growth, and maybe 0.75 yeast growth, and then bacteria will be from 0.8 water activity. So usually, but some kind of molds or fungi, they can be like osmotolerance, they can be grown until 0.6. So 0.6 water activity, at least some some kind of microorganisms can grow, but below that no microorganisms can grow. So obviously water activity and humidity also plays a role in preventing the growth of molds or the microorganisms. So if we see here in this figure at the bottom left, so we see temperature and moisture content and relative humidity. So if they are like uh, very high, so most of the like bacteria, fungi, insects, they can grow. But if uh, we decrease the relative humidity or moisture content, then what will going to happen? Bacteria cannot grow, only fungi and insects can grow. And then at the very low relative humidity, only like no microorganisms can grow. Like less than 0.6 microorganisms cannot grow, but insects can grow. At uh, at around 30 or 30 degrees Celsius, which is optimal temperature, and less than 0.6 6 to like 0.4 water activity, only insects can grow here in this range. So this graph is very good, which uh, precisely tells the combination of moisture content and temperature. So raw relative humidity means that water loss is very high. The product undergoes wilting, shriveling, toughening, and loss of flavor. So humidity should be maintained, and water permeability of the produced surface can be reduced by sometimes applying wax or edible coatings to the surface so that sufficient air will uh, like just the sufficient air will go, but water will not come out to remove heat respiration. And last is the physical handling. So they basically properly physical handling also should be done so that mechanical injuries will be less. So like rubbing, compression, impact, and vibration, which are during the transport, they can cause bruising, crushing, or puncture. So they can physically damage produce, which can increase respiration rate and generate more heat and ethylene. Damaged tissues, they basically decay more rapidly than and then this decay, they will spread and ruin the whole product. So it can be averted by using proper packaging material, and then we can use like stacking or loading uh, in the particularly in the vehicle. We should do carefully and secure the cargo within the vehicle by using aluminum or wood load racks, wood load locks, fiber boards, honeycomb fillers, or like we should use different techniques like made from fibers or wood. So we can provide some kind of cushioning effect. So wood blocking and nailing strips, and then insulated craft papers, airbags, and cargo nets and straps or wooden load gates. So we should uh, provide from all sides. We should provide some kind of cushioning, and we should properly handle that so that mechanical injury will be lesser. So from all these discussion, we can say that temperature is very important, humidity is also very important, and physical handling should also be appropriate. So all these are major factors to control the quality during the transportation. So let's discuss this question now. We have some questions. Okay, we are moving to this question now. Which of the following statements about handling fruits and vegetables is the correct? Gentle handling of produce helps prevent mechanical injury. Harvesting produce at optimal maturity is crucial for quality. use of dirty containers can increase microbial load. We should tell the correct statement regarding handling. Anyone? Option D. All. D. D means all. Okay, everyone is saying option D. So we know that there are different stage of fruits handling, like at the time of the harvest at the field, at the time of loading and unloading, at the time of transportation at wholesale market, and then retail market, and finally at the consumer end. So all at this stage, there we should have proper handling. And option D is correct, that gentle handling also prevents bruising and then other mechanical injuries. So there will be less defects. So option statement 1 is correct. And then harvesting at the optimum maturity ensures better flavor and shelf life. So this is also true. Then third is that dirty containers while handling in the field can harbor microorganisms, and because of that there is a risk of contamination. So this is also true. So option D is correct, as you guys rightly mentioned. Now let's discuss this match of the following question. Column 1, there are different handling like harvesting, unloading, and loading and transportation. Fourth is retail display. In column 2, they have the correct practices like avoid using torn bags and gentle handling to avoid mechanical injuries. Third is store in controlled environment. Fourth is use well pre-cooled. Which option should be correct, guys? Option B, C. B, C, D. So B is correct. Let's see. So when we are harvesting, so we should have gentle handling so that there should not be any mechanical injury. So harvesting is associated to second. Then loading and unloading, it requires avoiding the use of torn bags. So when we are doing loading or unloading, first is correct that we should not use torn bags. Proper transportation uses well pre-cooled vehicles. So for transportation, well pre-cooled vehicles should be used. Retail display benefits basically from when we are storing in controlled environments. So in retail display, we should maintain control environments and then store. So D is correct match. So this is our diagram of refrigerated van. So this is basically usually refrigerated where vehicles should be used during transportation. So which next question is which of the following statement is regarding air delivery system in refrigerated transports? So we have refrigerated transports and we have like different air circulation systems in that. One is like top air delivery system. Second is bottom air delivery system. So we should tell which statement is correct regarding that. So in top air delivery system, the refrigeration unit in the front of the vehicle blow cold air along the ceiling. In a bottom air delivery system, the air flows from the front to rear of the vehicle and is hosed through the cargo. Third statement is a typical top air delivery system is composed of an air delivery duct along the ceiling, horizontal floor conducts, and a return air bulkhead. Fourth is in a bottom air delivery system, air movement is horizontal. C option 1, 2, and 3, which is correct. So 1, 2, and 3 are correct options in basically top delivery system, which looks like this. So in this refrigeration unit, uh, so the refrigeration unit in front of the vehicle, it blows cold air along the ceiling. So uh, from ceiling to the basically a floor, from the top to bottom, the movement of air will be there. Cold air basically circulates above the cargo from the front to the rear of vehicle, and a typical delivery system is basically composed of an air delivery duct along the ceiling, then horizontal floor ducts and a return air bulkhead. So this kind of figure is telling that from ceiling, this is the air will come from ceiling to down. That's why top air delivery system. Whereas in bottom air circulation system, from bottom to top it will go. So the most air movement is vertical, not horizontal. The refrigeration system blows cold air in the T-beam floor of the container. This I'm so sorry that the power was off here, so the internet was disconnected. So we were discussing that in the air circulation system, the most air movement is basically vertical, not horizontal. The refrigeration system, it basically blows cold air in the T-bed floor of the container. This air flows from the front to rear of the vehicle and is forced upward through the cargo, as mentioned in the diagram, that it will be like this and it is forming T shape. So from the bottom, it will follow vertical route and then towards the ceiling, and it will form T kind of beam, like T kind of system. When the air reaches the ceiling of the container, it flows from the rear to the front and returns to the refrigeration unit through the bulkhead openings. The loading pattern should be such that entire floor is covered to force air up and through the cargo. Any uncovered floor space, for example, between pallets, the last pallet, and the rear doors must be filled with empty boxes, blocks, or insulations to prevent cold air from short circuiting to have better efficiency of the system. So this is bottom air circulation system. So in this option 1, 2 and 3 is correct and fourth is incorrect because it is saying that air movement in bottom air delivery system is horizontal while it is vertical. So is this question clear? Can we move to this next question? Okay. So which of the following statements about storage conditions for fruits are correct? Low temperature slows down the metabolic process. High humidity can cause mold growth. And third is controlled atmospheric storage involves adjusting gas composition. So this is about storage condition, how our storage condition should be there. Option D, which is 1, 2, and 3, all. So this is correct. 1, 2, 3 are correct. So low temperatures reduce the rate of respiration and enzymatic activities. So this is that's why the slow down the metabolic process. High humidity, they basically can indeed promote mold and bacterial growth. So high humidity will promote bacterial growth, and the controlled atmosphere storage modifies oxygen and carbon dioxide levels to extend storage life. So microorganisms like bacteria, they will like grow at 0.91 water activity, yeast above 0.85, molds 0.8, halophilic bacteria, they will be growing greater than equals to 0.75 water activity, xerophilic bacteria 0.65, and osmophilic, they are the most resistant. So they can grow in the water activity up to greater than 0.6. So if there is high humidity, obviously they all can grow. Bacteria, yeast, mold, and all kind of these bacteria also can grow. So, and obviously statement 1 is correct because low temperature obviously slows down the metabolic process, and C is controlled atmosphere means that we are modifying O2 and CO2 level and we are extending the storage life. So from this diagram, we can on the right side bottom, so they are showing that this diagram is in this, these are the apples. Basically, they are apples basically they undergo in cold atmosphere storage. So apples, they basically grow in India or anywhere in uh, the like season of winter season, they'll grow, and at the end of winter season they'll be harvested, and they will be put in the cold storage. So in cold storage, where there is uh, so that is basically the condition controlled atmospheric storage. So in the apples, then the apple will be supplied throughout the year in different part of the India. So uh, in controlled atmosphere, they can be put under like 1 to 3% of oxygen, and carbon dioxide level maybe 1 to up to 4%. They'll be stored, and the temperature will also be low, like refrigeration temperature, and they can be stored like that. And that's why the shelf life of apple increases maybe 6 months, 8 months. So these three statements are correct. Now let's discuss this question. Which of the following statements are correct about the general requirement for cold chain conditions? So like in the cold chain, these statements are telling about the cold chain. So which is correct? Like ensure food are transferred in a continuous operation. Cooked and uncooked food should be stored together. Frequent and systematic temperature checks using appropriate and calibrated instruments are required. And fourth is retail display cabinets can be overloaded to maximum storage. So we need to tell which statement is correct. C, option C is correct. Option C and 1, 3. Okay. Okay, let's see answer. So 1 and 3, which is option C, is correct. So everyone is correct. So basically in a cold chain management system, it is basically an integrated system in which food is kept cold in chilled or frozen form in an unbroken link from the initial chilling or freezing of freshly produced food at a farm or processing establishment through the stages of transportation, storage, distribution, and finally at the retailer. So in cold chain means that from uh, farm to fork, the cold situation is being maintained. So there are these general requirements which says that in the cold chain that maintain good manufacturing GMP practices at all the stages, and then ensure foods are transferred in a continuous operation. So this is correct. segregated cooked and uncooked foods. So this is correct, that segregation should be there. And then frequent and systematic temperature checks using appropriate and calibrated instruments should be there, and ensure retail display cabinets are not overloaded, and ensure all panels are trained. So first is correct, that there should be a continuous operation transfer, like the transfers in a continuous operation is correct. And then cooked and uncooked food should be stored together, which is not correct. They should be segregated. And then frequent and systematic temperature checks using appropriate and calibrated instruments are required, which is correct. And then retail display cabinets can be overloaded to maximum storage. No, this is wrong, that it should not be overloaded. So C is correct, 1 and 3 are correct, 2 and 4 are incorrect options. Let's now discuss this question, that which of the following is the bottleneck of the cold chain in India? Adequate transport facilities, sufficient cold storage network, lack of cold storage or warehousing facilities, proper cold chain management. Anyone? Vishakha is saying C. So she is correct, that this is C option is the bottleneck. So lack of cold storage or the warehouse facilities basically is identified as a major bottleneck in the cold chain in India. So adequate transportation facilities. This is basically not a bottleneck, because we have here poor transportation facilities, but it is saying adequate transportation facilities. So it is incorrect. And then sufficient cold storage network, but here poor cold storage network. So it is also incorrect. And D is proper cold chain management. So in basically there is not proper like poor cold chain technology. So it is also not maintained, and improper cold chain management is there. So which is saying that D option is also not correct. So this is they are the like option C only is the bottleneck. All are incorrectly mentioned. The statements are incorrect. So option C is correct answer. So we have these. There are different challenges in the cold chain industry in India. So the infrastructure is not good. The cold chain technology is also not good, and then power supply is irregular. Improper cold chain management, inadequate or insufficient capacity. If the cold chain are there, they have like the capacity is not sufficient, and then lack of storage, cold storage or warehousing facilities. So they are not proper amount of the cold storage, and also the existing one also not having advanced technologies, and poor transportation facilities, poor cold storage network, like when poor infrastructure. So in India, what happens if a fruit should be like it is at farm at maybe at low temperature, and when it is being shifted, maybe not in the refrigerated van. So because of that, there may be fluctuation of temperature or temperature abuse, which can lead to these chilling injury like these conditions in fruits. So, which is which can be taken care or which can be reduced if the continuous cold chain will be there. So, in that aspect, uh, improvement should be done. So strong measures should be done from the government side and other stakeholder side, so that the state of the cold chain is improved and the post harvest loss should be reduced. Let's discuss the next question, which is the primary purpose of quality control in post harvest handling: to ensure food safety, to maintain product quality, to comply with regulations, to not comply with regulations. So this is very simple question. Primary purpose of quality control in post-harvest handling. B. 1, 2, and 3. Fourth is incorrect. So everyone is B on B. Okay. So 1, 2, and 3 statement are correct. That ensuring food safety prevents contamination and illness. So food safety will be uh, like there if we reduce contamination and illness. So food safety should be maintained, and the product quality also we should maintain, so that fresh and the appealing product will be there, and complying with regulations, and so that the legal and market acceptance should be there. So these are the primary purpose in quality control. That's why we are doing quality control. Uh, and fourth is incorrect, to not comply with regulations. So let's discuss about hazards. So hazards are basically relative probability that harm or injury will result when substances are not used in a prescribed manner or in a prescribed quantity. So there are three different kind of hazards: physical, chemical, and biological. In the physical hazard, that means the physical material which is not normally found in the food, like wood will be there in food, or glass, or any kind of insulation, or stone or plastic. If they will be there in the food, it is known as physical hazard. In chemical, like chemicals which can be added either intentionally or intentionally to the food, like sometimes allergens, like from the peanut, from the almond, or from the milk products, or from like fungal toxins like mycotoxins, aflatoxins. They can be there like in the food product, and the phytohemagglutinin can be there. This is kind of a toxin, so that can be present, or alkaloids, this can be present. So these kind of the compounds, if they're present in food, so it will be chemical hazardous. And then third one is biological. So if the living organisms and various micro biological agents like bacteria, molds, they can be if present in food. So the biological hazard will be there in the food product. Let's discuss this question. Which of the following statements about biological hazards in fruits and vegetables are correct? So one is bacteria, fungi, parasites, and viruses are biological hazards and found in food. Second is the primary source of microbial contamination of fresh fruits and vegetables include untreated manure, contaminated water, contaminated soil, and poor sanitary practices. Third is contaminated water does not contribute to microbial contamination in fruits and vegetables. Fourth is untreated manure or feces, and multiple municipal biosolids are source of contamination. Let's see option B, 1, 2, and 4. So we are talking about biological hazards, which are you are correct. Like 1, 2, and 4 are correct. So biological hazards, they are basically the contamination with the bacteria, fungi like yeasts or the molds, parasites like protozoans and helminths, and also from the viruses. So these will come in the category of biological hazards if they found in food. Primary source of microbial hazards, microbial contamination can be like can come from untreated manure or municipal biosolids and sewage fluids accumulated in the plant, and untreated manure or feces and municipal biosolids. They are basically the contamination, source of contamination from where these bacteria or the fungi can come into food. Then contaminated water, which are used either at the agriculture field or processing step. So what happens? They can contaminate the fruits and vegetables. Also, soil, dust, surroundings, and poor handling of equipments can also lead to microbial contamination. Poor sanitary practices in the field as well as in the processing plant, or where the equipment or the material or where it is being handled. So if there is not proper cleanliness, that can also lead to biological hazards. So 1, 2, and 4, they are correct. So it is saying third is saying contaminated water does not contribute, whereas it contributes to microbial contamination. That's why it is not correct. Let's discuss this question. Which of the following naturally occurring chemicals in fruits and vegetables is associated with allergic reactions? Mycotoxins, alkaloids, phytohemagglutinin, and acidic proteins. So Vishakha is saying C, phytohemagglutinin, naturally occurring chemicals in fruits and vegetables which are associated with specifically allergic reactions. A, B, and C. No. Allergic reactions. Suraj, allergic reactions only. So B is alkaloids. Okay, let's see. Answer is D, acidic proteins. So what happens? The mycotoxins, which are the toxic compounds which are generated from certain type of molds or the fungi, they are the like they cause acute or chronic poisonings because they are the toxins, but they are not the allergens. They will not trigger any allergic reactions. Like if we talk about the mycotoxins, they like one example is aflatoxin, which is there in cereals, oil seeds, tree nuts, and spices. And another is ochratoxin A, which is found in cereals and cereal products, coffee beans, dry fruits, wine and grape juices, spices, and liquorice. Then third is petulin. So petulin is found in moldy fruits like apple. It more like when there is molds in the apple or rotten apple, Pathogen can be there as a toxic compound, toxin, and grains also. And fourth is fusarium. So from the fusarium species, this is bacteria. So fumonigens can toxins which produced by this kind of a species, bacterial species, and it will be in corn. And another toxin is uh, zearalenone. So it will this toxin and deoxynivalenol is found in wheat products, and another toxins like T2H2 is in oats. And this alkaloids are also like they have the compounds which produce acute and multiple and chronic multiple poisonings. So alkaloids can be pyrrolizidine alkaloids. So they what they do, they damage the DNA and cause cancer. Like they can be found in herbal teas, honey, herbal herbs and spices, and cereal products. These glycoalkaloids, these are another kind of uh, alkaloids. So they can found in tomato, potato, and eggplants. And the main compound is solenoids and caconines. So they are the alkaloids. Uh, they will create the poisoning. They will be found in such kind of products. Phytohemagglutinin is also a is itself a toxic compound, toxin name. So what happens? They will be found in uncooked or raw beans like red kidney beans or white kidney beans. Sorry, it should be right kidney beans. And this acidic proteins. So what happens? Just not the acidic proteins. The overall the one, and in that protein specifically proteins, they are the most compounds, so they cause allergic reactions. So because these acidic proteins, because of their chemical structure, and they can be not denatured, they will be in intact form at low pH also, so they are more resistant. So what happens, since they have the chemical structure and charges which allow them to resist denaturation, and they will not digest in the stomach's acidic pH. So what will happen? Because of that, they will reach to the gut intact and can cause or can trigger some kind of immune responses. Because of that, allergic reactions may occur, and so these acidic proteins are basically causing allergic reactions. Like in peanut, many people are allergic to peanut. So in peanut, this kind of AH1 protein is there, and some are allergic to some kind of nuts like Brazil nut. So in that BER1 protein is there. So these proteins, they will trigger an immune response. Because of that, allergic reactions will be there. Is this question clear? Can we move to this match the following? Okay. So in column 1, quality control measures are there like sanitation, temperature control, traceability, and inspections. In column 2, uh, their purposes are given like prevents microbial growth, ensures cleanliness, tracks produce handling, and fourth is verifies compliance. So already we got two answers from Kavi and Suraj. So they are saying D. Let's see. Yes, they are correct. D is the correct answer. So sanitation ensures cleanliness and reduce contamination Temperature controls prevent growth by maintaining safe temperature, and traceability tracks the origin and handling of produce. Inspections verify compliance with safety and quality standards. So this was the last question for today. So if you have any doubt, you can ask. So we discussed all these topics today. So we discussed about post-harvest causes and preventive measures, factor affecting deterioration of fruits and vegetables, and we discussed about post-harvest physiology of fruits and vegetables, and then preventive measures for minimizing post-harvest losses. Then we discussed about post-harvest operations, primary process operations, second, tertiary operations, pre-cooling technologies, discussed about hydrocooling, cryogenic cooling, and then we discussed about handling and transportation of fruits and vegetables at different stages. We discussed about air circulating system in a refrigerated vehicle, like top air circulating systems and bottom air circulating system. And then we discussed about supply chain management and storage. In that, we discussed about chain management and cold chain management. Then we discussed about UN. We discussed about food safety and hazards. In the next discussion, we will be taking basics of processing and preservation, processing by removal of water, processing by addition of heat, processing by removal of heat, and irradiation of fruits, vegetables, and spices. And this is the link of my YouTube channel. In Google Drive, I'll be uploading the PPT. And this is the Q&A group for discussion forum for this particular course. So thank you for joining. Also, like I wanted to tell something, to discuss something. So in this question 5, are you able to make this question? So this is about activity, calculating water activity in question 5. So there, here it is given mass of the water, which is 1 kg, 1000 gram, and its molecular weight is given 18 gram per mole. So from this we can calculate of water, right? 1000 divided by 18. This 200 gram of KCl is given, and molecular weight of KCl is given as 74.55 gram per mole. So from this also moles can be calculated, and from mole fraction can be calculated, and then water activity can be calculated. So I just wanted to give you hint to solve this question. So have you question got the answer? Air circulation theoretical explanation. So air circulation means how the air is circulated. So this is the theoretical explanation, right? So what is happening? Like this is a refrigerated vehicle is there. So what happens here is first one is a liquid nitrogen tank. So from this heat exchanger is connected. So all the in this wall heat exchanger will be there. So from this the cold air will be formed and cold formed, right? So if this kind of air circulation system is flowing air from like this motion, like from ceiling, it will go and it will go to the end of the vehicle, and then it will flow uh, in different channels like uh, and also to the bottom, and then from bottom it will release. Then it is the cold top air delivery system. in bottom circulation system, what happens? Air is flowing from bottom to top, and here like these kind of channels will be there. So from floor there will be like some kind of vertical pipes will be there in between also until the end, and then all the air will be collected from the ceiling. So this kind of system is bottom one. So Suraj, is the clear? Are you there, Suraj? Yes, ma'am. Okay. So both assignments 1 and 2 both should be submitted on the same day, which is 6th of August. So please try to submit on time. And if you have further doubts, you can write in Q&A section. So thank you so much for joining. Let's meet on 10th August, 4 to 6 p.m. For our third session. And thank you so much for joining.
Thank you, ma'am.
Okay, thank you.